Okay, this will be the sample video for 2017 for the Advanced Math Unit 3 test. Okay? Alright, so we're doing composition. They want f of g of x and then g of f of x. So if I do f of g of x, I'm starting with the f function. I take out, first step is to take out the x. Then I'm going to put in the g function. Okay, and since it ends with x, I'm going to distribute that. That's negative 3x squared. Negative 3 times 3 is negative 9. Okay? What I'm going to do, I'm going to make sure my calculations, negative 9 plus 2 is a like term, so negative 3x squared minus 7. So that's the answer for A. I'm going to switch to blue. Okay, then I'm going to do g of f of x. Alright, so if I do g of f of x, I'm going to start with the g function. I'm going to put in the f function. Now, what this means, squared means I make a box, negative 3x and 5, negative 3x and 5. So that is going to be 9x squared, negative 15x, negative 15x, and 25. The like terms, it's all multiplication. Then I'm going to combine those like terms. Negative 15 minus 15 gives me negative 30. So I got 9x squared minus 30x. Now, you've got to combine the 25 and that 3, which will lead to 28. Okay, so this would be the answer for B. Okay, let's go down to this part. So I got f of g of x is what I'm doing here. So I'm going to start with the f function. I'm going to put in the g function. Distribute 1/3. Use your nice fraction button. I don't have that, but I would just use your nice fraction button. Times 3. 1/3 times 9. So I got 1x plus 3 with this minus 4 here. This and this will combine to negative 1. Now this one I'm going to do g of f of x. So I'm going to start with the g function. I'm going to put in this 1/3 x. Okay, minus 4. Multiply 3 times 1/3 is 1. 3 times negative 4 is negative 12. Combine those, negative 3. So go 1x minus 3, that would be my answer for B. Okay? So once again, this part's f of g of x. So I'm going to start with f. Oops. Sorry. I'm going to start with the f function. I'm going to put in the g function. Okay, now all I can do there's a 1 here. So if I distributed that, that'd be 1x cubed plus 2 plus 5. These combine here. So that would be 1x cubed plus 7. Okay. All right, this I'm doing g of f of x. Okay. So I'm going to start with cubed plus 2. I'm going to put in this x plus 5. Now what this means is multiply it 3 times. Okay? And then add the 2. So what I'm going to do is I'm going to make a box and do x and 5. So that's x squared and 5x. 5x and 25. So those combine to x squared plus 10x plus 25. Now, what I'm going to do is I'm going to do a third box and do the x plus 5. Okay, so x times x squared would be x cubed. 5 times that would be 5x squared. X times 10 would be 10x squared. 5 times 10x would be 50x. X times 25 would be 25x. And 5 times 25, I'm going to have to do that one. It's 125 just to show you. Okay, now, I got x cubed here. Here's a good rule of thumb. The diagonals will combine. So I got 5 and 10 be 15x squared. 50 and 25, which would be 75x. And now, this 125's got to combine with this 2 to give me 127. Okay? All right. So they want us to evaluate f of g of x. So I start with the f function. I'm going to put in the g function. Now, when they put this -2, all you got to do is evaluate it. Okay, -2 for x, and then 3x minus 1 squared plus 4. I get 53. Okay, g of f of 4, I do 3 parentheses minus 1. I'm going to put x squared plus 4 in there. And now what I'm going to do is I'm going to store the 4. So 4 arrow x, execute, 3 parentheses x squared plus 4 minus 1. So I get 59 there. Okay, going to the next page. All right, f of g. So f function, g function. Now, you've got a nice calculator that will keep this underneath. What I have to do is store the 3. Mine's a little different. I'll do square root, parentheses with the 2x, minus 3. I got to close them. Now yours, you don't have to close them because it's already underneath. Okay, that's going to be 1.73, or your calculators will give you a reduced radical. G of f of 2, so g, okay, all right, and then when I put that in there, you'll see what happens here. 2 for x, or 2, parentheses, or 2 square root, parentheses, x minus 3, and it's going to say not possible, so we'll just write not possible. Okay, 8, okay. Now this is where you work backwards. You work backwards here, all right. So what I do is I go to 3, and I go to 3 here. So I start here, then I go to g. So g of 3 gives me 5, okay. So then I got f of 5. So what's going to happen is I'm going to go to 5, and then to f, so that would be 4. This starts at 5. They want me to go to f, which would be g of 4. So I'm going to go to 4 and then go to g. It's going to stay 4. Then g of f of 6. So I'm going to start at 6, go to f, which would be 3. So now I'm at g of 3. 3 there to 5. Okay? G of 2. 2 would be here. Going down to g would be 1. F of 1. So 1 to f, -5. Okay, a lot of different answers in this. The idea behind this composition, okay, you could think of it as almost reversing back. So that's in parentheses. If we're doing f of g of x, then that's got to be what's going inside. Okay, and that's the thing that it starts with. Think about it. If I started with f, I would go 1 space cubed, and then I would fill in g. That's the same idea. Okay, on this one, it's the same thing. Okay. Now, there's a lot of different answers, but I would look at that that's underneath. That's x squared minus 2. Okay, if I took out x squared minus 2, what would I have? I would have this, which would just be x. So that would be the square root of x. And think about working backwards there and how that would work. Okay? All right, we're going to handle this a little bit differently in my class. Let's just check the inverses. All right, so here's the idea. That for this to be the inverse, this would be x first, and then this would be minus 5. And then I would divide each of these things by 2. So that would be 1/2 x. Okay, -5 divided by 2 is -5/2. Does that match that? That answer would be no. Okay? This one, I would start out with, I would start out with squared. Come on. Start out with squared. All right? That plus 3 goes outside minus 3. That's good. Then if I work the other way, okay, what I would have here, the opposite of squared would be x. That's minus 3 on the outside would become plus 3 on the inside, which matches. So that answer would be yes. If you're in the other classes, you'll show composition of functions to get the same result. All right? Now, find the inverse of each function, then list the domain and range. Okay, so for line, it's going to stay line. I'm going to go ahead and make that 1x. That's going to go from plus 9 on the outside to minus 9 on the inside. Now here's the key. Whatever number is here, you're going to divide both of these by that. Okay, so what the inverse is is 1/3 x minus 3. Okay? Now, what I want to do is find the domain and range of the inverse. Now, if you want to actually plot out a little bit of a line, you could go to the table. All right? And I'm going to show you something in a second. All right? But what I would do, use your nice fraction button. All right? I don't have it on my calculator. All right, table. So I'm going to go 0. I'll be at -3. All right, and I'll go 1, -2.6, 2, -2.3. Okay, -1, -3 point something. Okay, and then -2, -3.6. So what I got is a line. Now, if I label that, that's infinity, infinity. This is negative infinity, negative infinity. Now, so my domain, smallest x value, negative, biggest is positive. Smallest y is negative, biggest is positive. Now, here's a good rule of thumb. Line will always have these two results. Okay, because a line produces a line in inverse, and that line will be a function. Okay? Moving on to 17. So immediately I see that's a line. I'm going to save myself some time. I already know these answers. I'm not going to even mess around with that. I already know the domain and range of a line. Now here's how I would do this. This would be x plus 5/6. With a 1 there, I'm going to divide each of those by 2/3. So use your nice fraction button. Okay, 1 divided by 2/3 is 3/2. So I got 3/2x. 5/6, use your nice fraction button, divided by 2/3, use your nice fraction button, gives you 5/4. So that right there, 3/2 x plus 5/4 would be the inverse. Okay? 18. The opposite of x squared is square root of x. This is plus 4 on the outside, so it's going to go to minus 4 on the inside. So what I want to do is I want to get an anchor point here. Alright? So when I graph, I'm going to graph 4, 5, 6. Alright, I've done that. 3 and 2. Alright, I'm going to use my table. Okay? Square root. Alright, x minus 4 all stays underneath. Table. Alright, 5 gives me 1. Okay, 6 gives me 1.4. And then if I try to graph 3, I get an error, can't do it. Error, can't do it. So what has to happen is that goes like that. Now when I label this, this is 4, 0. This is infinity, infinity. Okay, so the answer to this first one was this. Alright, smallest x value is 4. Biggest is infinity. Smallest y value is 0. Biggest is infinity. Okay? Alright, 19. Alright, so the opposite of a cube, okay, is a cube root. This is plus 1 on the outside, so it would be minus 1 there. Okay, so that's my function. So what my anchor point is 0, -1. So I would graph 0, 1, and 2, -1, -2. Okay, let's go to the table. Okay, cube root. The way you get cube root, shift. Okay, and I got x minus 1. All right, so 1 is at 0. All right, 2 is at 0.25. Okay, then I got -1, which is down at -2. And then I got -2, which is at -2.2. So here's what it looks like. So what happens is that's infinity, infinity. This is -infinity, -infinity. Okay, my anchor was 0, -1. Now once again, smallest x value is -infinity. Biggest is infinity. And then the same thing for the range. It's very similar to a line. Okay? All right? Moving on. I've got 20. All right, so this is, whoops. So what I would do is I'd have squared. Minus 5 on the outside, inside becomes plus 5 on the outside. So that would be the inverse. Okay, so my anchor point is 0, 5. Okay, I go to the table. All right, I'm going to graph 1, which is up at 6. I graph 2, which is at the 9. I didn't leave myself a whole lot of room. I'm just going to estimate that to be in somewhere up here. And then I'm going to go negative 1, up at 6, and negative 2, up at 9. So what I got here, when I label this, is this would be infinity, infinity. This would be negative infinity, positive. This would be 0, 5. So my smallest x value, still negative infinity. Biggest is infinity. My smallest y value is actually 5. And I use a closed bracket because it's at a point like that. Okay? All right, couple left here. All right. Okay, so I got this. This would be square root. The plus 4 goes out here. The minus 9 comes inside as plus. Now, this 3 is 3 times the outside. So the opposite of that would be 3 divided by the inside. Okay, now, your anchor point still going to be the same. Anchor point would be negative 9. The negative 9, negative 4. Okay? It'd be right there. All right? Now, that means I would want to try to graph negative 8 and negative 7, negative 10 and negative 11. So I'm going to go to the table. Okay? Now, I would use my nice fraction button. So I would type square root, and then I would put the fraction button in there. I have to actually physically go, this is sort of weird for me, x plus 9, then hit division of 3, and then close it. Yeah. Okay? With a minus 4 on the outside. Okay? So then I want to try to graph negative 9. Let's just double check. Yep, it's at negative 4, negative 8. It's going to put me at negative 3.4. And then negative 7. It's going to put me, it's going to be like this, somewhere like that. If I try to graph negative 10, it's going to give me error and likewise. So what I have is this. Okay? So this is infinity, infinity. Okay, this is negative 9, negative 4. Okay, my smallest x value is negative 9, biggest is infinity. My smallest y value is negative 4, my biggest is infinity. Okay, moving on to 22. I think it's the last few of these that we have to do. Yep. 22. Make sure camera's still running. We're good. Okay, so the opposite of that would be squared. Minus 5 to plus 5, plus 1 to minus 1. Now this is 2 times the inside. So I would divide it by the outside. Now, what I have to do, I got to put a 1 here, I'm going to divide that. So that's going to be 1/2 x minus 1 squared plus 5 divided by 2 ends up being 2.5. So my anchor point is 1, 2.5. So my inverse is 1/2 x minus 1 squared plus 2.5. Okay? So 1, 2.5 up. So I'm going to go into the calculator. 1/2 x minus 1 squared plus 2.5. All right? If you divide 5 by 2, that's what you get. Okay? If you want to check, that's 1 and 2.5. Pretty easy. 2 is 3. And then 3. 3 is 4.5. It's already there for me. Then 0.
Good afternoon, Osborne Park. Please listen for your afternoon announcements.
Okay.
Seniors, if you have an appointment for pictures today, it has been canceled and rescheduled for this Thursday after school in room 2A. Please use your same schedule.
So if I label that, that's infinity, infinity.
Support the Muslim Student Association.
That's negative infinity, positive infinity. This is 1, 2.5.
$5
So my smallest x value, negative infinity, biggest is positive.
will be served.
Smallest y value is 2.5, biggest is
All
infinity.
interested members, please attend. Seniors, don't
Okay?
forget that.
When you do these graphs, what you're going to want to do, pick out some points.
Mr. Labonte, room 3034.
So that's negative 2 over 1, 2. So that's negative 2, negative 2. This is negative 1, negative 1. This is 2, 0. So the idea is you swap the x and y. So that stays, now it'd be at 0, 2. So what ends up happening is it goes like that. Okay? This one's probably going to be a little bit better. This is 1, 3. This is 2, 2. That's not that much better. This is negative 2, 0. So what would happen is this would become 0, negative 2. This would become 3, 1. And that stays 2, 2. So what would happen is, and let's do one more. That's negative 4, negative 1. So I would be at negative 1, negative 4. 1, 2, 3, and 4. Okay? So it goes a little bit like this. It goes boom, boom. Okay? All right? Boom. And let's say, what's this point here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They go right like that. Okay? All right? So it's like a flip. Okay? Swap the x and the y values. So if you've got negative 2, 0, that would become 0, negative 2. Okay? All right, how many pages we got left here? I think this is the last page. All right, so what the directions say here, graph the given function and its inverse. Couple of ways you can do this. Okay? If you want to graph the function, figure out some points for this one. All right, so you got your function and you got your inverse. Okay, so 1/4 x, and some people would prefer to do it this way. All right, so let's say I pick 0. That's 0, negative 3. Okay, 1. 1, negative 2.75. 2. 2, negative 2.5. Negative 1. Negative 3.25. And negative 2 would be negative 3.5. So, what you can do, pretty easy. Graph 1, 2, and 3. 1, 2.75. 2, negative 2.5. All right. Negative 1, 3.25. Negative 2, this. So this is what you got for the original. Okay? Now, to get the inverse, flip those around. Negative 3, 0. Negative 2.75, 1. Okay? Negative 2.5, 2. Okay? Negative 3.25, negative 1. And then negative 3.5, negative 2. So what you got, the thing in red, becomes your line. So all you got to do is flip them. Okay? You could, let me show you a different way of doing it. You could just go, okay, this is going to be 4, 0, 2, 3, 4. And you plot your points. Okay? Okay, so I got 5, plot 5, 5, 1. Okay? Well, let's just stay with that idea. 4, 0 is the anchor. Okay? So I'm going to go 0, 4 for the other. Actually, no, we can't do that. Hold on. Hold on, can't do that. Let's go, let's just plot this one. 4, 0, then 5, then 6, 6, 4. Okay? Actually, this is the original, so I'll put this in blue. Alright? And then I'd plot 3, 3, 1. Whoa, okay, hold on. 3, 1. Then I'd plot 2. It's 2, 4.
Edie Drummer, if you're in the building, please come to the main office. Edie Drummer, if you're in the building, please come to the main office. Thank
Now,
you.
the inverse for that, pretty easy, would be square root of x with a plus 4, so that's 0, 1, 2, 3, and 4. And then what I would try to graph is 0, 1. 1 would be 1, 9. No, that's not right. What did I do here? Oh, whoops, I never put that in. Shift, whoops. Shift, X underneath, plus 4. Okay, 1, 5. Okay, then 2, 5.4. Okay, if I try to graph negative 1, I can't. So that's why it's that. Okay, and then this last example, okay, the anchor point there would be negative, for the regular one would be negative 3, negative 7. So it'd be here. So if I'm at negative 3, obviously I'd plot negative 2, negative 1, negative 4, and negative 5. Okay, so I plot negative 2, it's at negative 5. Okay, then I plot negative 1, which is negative 1, 1. Then I would plot negative 4, which is negative 5. And then I plot negative 5, which is going to be back up here at 1. Here's the original. Okay, now the inverse would be square root of x. Seven would now be on the inside. 3 would now be on the outside. This would be, it's 2 times the outside, so I'm going to divide in here. My anchor's still going to be negative 7, negative 3. The anchor points are going to be completely flipped. Some of the other points you're going to have to look at. Okay? So, for instance, I would do square root. Use your nice fraction button. No, divide by 2, sorry. Okay, so what I got here is I would plot negative 6, get negative 2.2, and then I would plot negative 5, which gives me exactly negative 2. And if I try to plot the other way, like negative 8, it gives me an error. So I'd plot that way, and let me put that in red so you can distinguish it. Okay? That's pretty much what you have to do, is plot those points. Okay? To practice that, you should do well. There is a lot of work, though, to the chapter.